Hi, welcome back. Today we are going to be studying inverses, and specifically inverses of cubic and cubic root functions. This first page, this entire page, is going to be a you-do session, so please take the time now to go through it and get it all taken care of so that tomorrow when you begin class as your warm-up, you're able to hold discussions about the answers to these questions, not rapidly try to fill them out. All right. Question number 5 is where we're going to begin today. We're going to start by finding the inverse of these functions. This process should be fairly familiar to you by now because this will be the third time that we've actually utilized this process. +1. All right, so now we've switched x and y. We're going to start moving numbers so that we've isolated the radical. Now that the radical is isolated, I'm going to cube both sides. That's going to give me x minus 1 cubed equals y minus 6. Adding 6 to both sides will be my final step, and I get y equals x minus 1 cubed plus 6. And the final step of this process is to switch back into function notation, and that's going to be x minus 1 to the third power plus 6. Question number 6. We're going to use our graphing calculator to study this graph. So let me go ahead and get that up. Go back into y equals so you can see what I've done so far. I've simply put that into the equation, and now I'm going to graph it. All right, now it's asking me if it's 1-to-1. So remember from our fall semester that 1-to-1 means that it's going to pass a vertical line test and it's going to pass a horizontal line test. That's going to be the determination of 1-to-1. What that means is that both the function and its inverse will be functions. So now let's go ahead and pass the vertical line test first. Some of you may be familiar with this function. If you're not, go to Second, Program. That'll bring up your Draw menu. I'm going to bring up a vertical line by hitting 4. And this is kind of fun because now what I can do is I can run my vertical line back and forth along this graph to see if there are any places where it fails the vertical line test. So it's just another way for you to utilize technology to help you see if it passes the vertical line test. All right, so the vertical line test holds true. That means that so far the graph is a function. Now we're going to do the horizontal line test. The horizontal line test, we have to go back to y equals 4, but I'm going to go ahead and pick a place where I know it's going to fail so I can show you what to do. So I'm going to go ahead and pick 3, and down in y2, I'm going to put y2 equals 3. After graphing that, you'll see this, and how many times does the graph touch the red line? In this case, it's 3 times, so it fails the horizontal line test. What that means in this particular question is the graph G is not 1-to-1. And then what does that mean about its inverse? The inverse, G negative 1, is not a function. All right? Moving on to question number 7, we're going to determine without graphing whether the inverse of the function is or is not a function. Okay, so the first explanation I'm going to give in this particular case is that the inverse of a cube is a cubic root, and therefore a cubic root, being one of the parent functions, is a function. The second explanation I would give is by solving it algebraically. I'm going to go ahead and do x equals y plus 5 cubed. Take the cubic root of both sides because that cube is isolated. So I get the cubic root of x equals y plus 5 subtract 5 to both sides, and now I get y equals the cubic root of x minus 5. And now, because this function is a parent function, you can see that the inverse, g negative 1 of x, is in fact a function as well. All right, question number 8. We're going to graph, that has been graphed for us. We're going to sketch a graph of f negative 1 on the graph. Seems like it's a little bit out of order, so I'm going to skip down to C to solve the equation first algebraically. So we're going to do x equals 1/2 y minus 2 cubed. Remember, I'm not going to cube root this yet because this isn't isolated. First things first, multiply both sides by 2 to get rid of that 1/2. 2x equals y minus 2 cubed. Now I'm isolated, so now I'm going to cube root both sides. That gives me the cubic root of 2x equals y minus 2. Add 2 to both sides. And f negative 1 of x is the cubic root of 2x plus 2. So then from there, what I can do is I can go ahead and utilize some of my understanding of transformations to graph my critical values. So here I am here. All right, there I am there. Remember, that's a compression of 2. That's why I'm putting those dots in the middle. That does not belong there. Let's put it in the right place, please. And then this one is here. And then this one is here. So remember, that's just using transformations of parent functions to graph this thing. And there we go with that one. And there we go with that one. And there it is. For those of you who remember the line of symmetry, there it is right there. The equation of that line of symmetry is always, always, always y equals x. That has never wavered, nor has it faltered. So we've gone back to A and we've sketched it. Find the domain and range of both. That's going to be negative infinity to positive infinity, and also negative infinity to positive infinity, giving the domain and range of both. All right, does the domain of f need to be restricted to ensure that f negative 1 is a function? The answer to that question is no. And the reason why is because you're looking at a function which has no restriction in either its domain nor its range. Therefore, its inverse will have no restriction in its domain nor its range also. All right, and that is the explanation given here. Odd indexes don't have restrictions. Even indexes do. So that's another thing to consider also when you're looking at these. All right, so if you have any questions, please make sure that you're getting them answered. If you haven't gone ahead and done your inverses exploration at the beginning of the notes, please do so now. Thank you.